Aircraft engines of any type passes different bench tests by the manufacturer before being released to be attached in the aircraft wing or fuselage as a power plant to produce necessary thrust for the aircraft. Like other units and parts of the aircraft engines have time, which is mainly limited by the cycles. One successful takeoff, and once we for example set the takeoff thrust on an engine, either full takeoff thrust or reduced takeoff thrust will be calculated as a cycle. So let's say if an engine has, for example, 8,000 cycles, so 8,000 cycles means that we can perform 8,000 takeoffs with this engine. Once the number of the cycles is completed, then the engine should be removed from the aircraft and should be sent to an MRO for the overhaul. So what does the MRO will do? The MRO will disassemble the engine, and based on the procedures they will perform the tests and replace some components which are also lifetime limits, and then they will assemble the engine, perform some tests on the bench or the bench tests, and then release the engine back for the service. And now the engine will have new number of the cycles, maybe the same cycle that it had or before, or maybe with the lesser cycles, and then it can be attached back to the aircraft. Since engine is a very complex mechanical unit composed of different sensitive parts or life limit parts, like the compressor, like the turbine, like different shafts, and for example the combustion chambers where the air and fuel is mixed and burned, so like other units there is chance of engine failure, there is chance of engine fire, and even a newly manufactured engine which has newly been manufactured by the manufacturing company does not have any guarantee that the engine will not fail. But anyhow, due to the complex task and work that the manufacturers are doing on the engines, chance of engine failure and engine fire is very less. But anyhow, we as pilots should be truly familiar with the different procedures which are released by the aircraft manufacturer, what to do if an engine fails. So we know that we have different phases of the flight. For example, starting from the takeoff, then we have initial climb, and then we have climb, cruise, descent, and approach and landing. So we have different procedures and different rules to follow based on the non-normal checklist. If we lose one engine in case of the twin engine aircraft and these phases of the flight, so they are not the same. Procedures are not the same. They have some we have some different methods for each one. If you for example remember in some of the flights that you are going, you see some empty passenger seats, or you can be informed that we have some space to still accept the luggage in cargo, but we are ignoring, we are not taking it. Even passengers are waiting in the terminal to be boarded, but we ignore to board full or to have full seat passenger. This is why, because we as pilots or flying crew and dispatchers, because of the safety of the flight, we always calculate the performance of an aircraft as based on the net performance. So in case of the twin engine aircraft, the net performance is the performance of the aircraft based on a single engine. So always we consider this. This is one of the safety precautions that we are always applying or doing. For example, based on the airfield that we are performing the takeoff, based on the elevation, based on the temperature, and any other factors and obstacles that we have around the airport, we just calculate the net performance of the aircraft. We always consider, so let's say if we fail one engine after takeoff, will the aircraft be able to still stay in the air and let us to fly the bird and return back to the origin airport, or at least to fly to another alternate airport and make a safe landing. This is why we are not always accepting full passengers, full luggage, and full cargo. So chance of engine failure in different phases of the flight, namely starting from takeoff, initial climb, cruise, descent, approach, there is chance that the engine will fail or the engine will go to fire. But it's worth to mention that an aircraft is not like a stone. So in any rare case, for example, if even we fail both engines, or we lose both engines, or in other words, if both engines fail, in case of the twin engine aircraft, the aircraft will not fall down on the ground like a stone, because we have wings, and still wings produce some amount of the lift, and there is a chance to make another safe landing. Let's call it safe, because even we do not have both engines available. Hopefully everyone remembers the US Airways flight 1549, if I'm not wrong with the flight number, Airbus 320, which got bird strike after takeoff, and both engines failed. So the aircraft did not fall down on the ground, and pilots could manage. They informed the ATC, and they immediately turned back to land in the original airport. But because of the long distance that they had with the airport, the captain decided and landed on the river, which we call it the ditching, and still they could survive all the passengers. So there was no one to be killed, no one to be seriously injured. This procedure is the gliding. So we glide still if we lose both engines. But if we lose single engine, still we have very safety precautions, and we have safety procedures based on the non-normal checklist and other procedures to keep the aircraft in the sky, and then to go and land safely in one of the airports. Among the different phases of the flight that we mentioned before, the longest, smoothest, and let's say safest phase of the flight is the cruise. In this phase of the flight, crew are relaxed from the overload and overwork, and then cabin crew are relaxed from doing services, the food and beverages for the passengers. Passengers are mostly busy with the cabin entertainment provided for them by the airline. In this phase of the flight, we are flying in almost smooth and calm here. Just in our cruising altitude, let's say 37,000 feet, 42,000 feet, or any other levels. Chance of engine failure in this phase of the flight is also something that we cannot ignore. For example, as passenger, you are sitting in your seat, and you are busy with the entertainment, and suddenly you hear that there is some change of the sound, which you hear from the engines, and then you feel that the aircraft is slightly yawing to the left or to the right, following by an announcement from the captain that they have lost one engine, and they are now flying with single engine, and they are proceeding to an alternate airport to make a safe landing. Now forget that the aircraft will fly to the destination, providing there is long way to fly to the destination. Now please sit quiet and listen to the safety instructions, which will be given to you later by the cabin crew, and let us go to the cockpit and see what the pilots will do if they lose one engine during the cruise for any reason. Now let's say we are in the cockpit, and we are watching the captain, watching the first officer, what they are doing, because they lost one engine. So what safety precautions, what procedures they are complying and applying that to make the aircraft safe. The first thing that is worth to mention is that once we lose one engine during the cruising altitude or during the cruise phase of the flight, the first and immediate thing that we should perform and think about is to descend to lower altitudes, because having single engine, and due to the low pressure and low density of the air where we are flying now, the single engine will not be capable to produce us enough thrust and to keep the aircraft in that level. So we should decide to descend to lower altitudes. Descending to lower altitude has a benefit that we enter to an area of high pressure and high air density, and the single engine that we have available, either engine number 1 or engine number 2 in case of the twin engine aircraft, will be able to produce us enough thrust to let us stay in the air and proceed to one of the airports and make a safe landing. So descending to lower altitude is called the drift down. So we should select a drift down altitude, where to and which level to descend. Besides descending to lower altitudes, we should keep in mind that we need to fly forward as well. We need to fly some distances over the ground just to reach to an airport. Besides descending to lower altitudes, so the ATC should be informed immediately, because they should know that this aircraft is in an emergency and they have lost one engine, and we should leave the airway by selecting another heading for the aircraft, either left or right. It's essential that we should leave the airway, because mostly we have another airplanes flying at the same airway, either 1,000 feet below or 1,000 feet above if we are flying in the RVSIM area, and we should leave the airway and select another heading, either left or right. Besides this, we should comply the non-normal checklist procedures, start the EPU just to supply electrical power to the failed, for example, electrical bus which was supplied previously by the generator which was in the failed engine, and then we should comply with the non-normal checklist. But before we read the non-normal checklist, there are some other procedures that are very essential in case we lose one engine during the cruise. The first one is we should set the max continuous thrust before starting the drift down. We should set the max continuous thrust on the live engine. So generally there is no need for the pilots to go to the manuals and see the performance calculations. We have the FMC, or flight management computer, available. So this computer will give whole data for the pilots. This is a very good help for the pilots, in fact. So normally we select the N1 limit page. From the N1 limit page we find out the percentage of the N1, which is the MCT, or max continuous thrust. So the pilot flying will disengage the auto throttle and set the max continuous thrust on the live engine. Then in the flight management computer we select the cruise page, and then from the cruise page we select engine failed prompt, and then we select which engine has failed in the new page. So the new page will display either left or right engine. We select, let's say for example, right engine has failed, so we select the right engine prompt, and then the new page which will be displayed will give us the whole data. First, from this page we find out the maximum altitude, which is the drift down altitude, where we should descend. So this is the altitude that the aircraft will be capable to fly with a single engine. This altitude is calculated by the flight management computer based on the current weight of the aircraft. As much as we are light weighted, for example, we have less passengers, we have less baggage and cargo, so the drift down altitude calculated by the flight management computer will be higher. But as much as we have more number of the passengers and the luggage and cargo, so the drift down altitude calculated by the flight management computer will be lower, meaning that we should descend to lower altitude, as we said before, because of the higher air pressure and density, to let single engine to produce us enough thrust and let us stay in the air. Once the drift down altitude is just observed or got from the flight management computer, we need to put this altitude in the altitude window of the mode control panel, or MCP, and then the FMC page will display as the drift down speed. So we need to set the drift down speed as well in the mode control panel, in the speed window. So what is the drift down speed? The drift down speed is the minimum drag speed. This is very important that we should perform the drift down to lower altitude, to the drift down altitude, which is calculated by the flight management computer, having this speed, because this speed is the speed which the aircraft will be subject to lesser drag. So this is the for example, minimum drag speed for the aircraft. Why? Because if we perform the drift down with the higher speed or lower speed, or a speed which is higher or lower than the calculated drift down speed by the flight management computer, more drag will not let us to fly more horizontal distances. Okay, we can descend, no problem, but we will not be able to fly more horizontal distances, because besides descending to lower altitude, we just want to be closer and closer to the alternate airport to make a safe landing. So once we set the max continuous thrust on the live engine, and then we put the lower altitude and altitude window of the for example mode control panel, and then we set the drift down speed in the speed window of the mode control panel. Now still we are flying in our closing altitude. We have not started drifting down, just we let the aircraft speed to reduce gradually. And in fact the aircraft speed will reduce gradually. Why? Because since we have only single engine available, so the autopilot will slightly pitch up the aircraft in order to have more angle of attack on the wings, and to produce more lift and let us fly in our current altitude. So this will cause the speed to gradually descend. Once the aircraft speed reaches to the drift down speed, which we have already set in the speed window of the mode control panel, we press the level change. So the level change is an autopilot mode. In fact, the autopilot is engaged, and this is strongly recommended that the aircraft should be flown by the autopilot. Manual flying is not recommended. Why? Because we need to reduce the workload and let the pilots to perform their duties and tasks. So the aircraft will gradually pitch down and start the descent towards the drift down altitude, having that drift down speed, which is the minimum drag speed now. So besides descending to lower altitude, we fly more horizontal distances on the ground as well. In fact, ATC has been informed before we perform these procedures, and we have left the airway. Now, in order not to be in a hurry, all tasks are divided between the pilot flying and the pilot monitoring. So pilot flying has his own or her own duties and responsibilities, and pilot monitoring has his or her own duties and responsibilities. So the responsibility of the pilot flying is to fly the aircraft, and the responsibility of the pilot monitoring is to read the checklist, do the communication with the ATC, and besides all, one important task that the pilot monitoring should do is to calculate the MEA, or minimum en route altitude, because in the route that we are, or off-route that we are performing a drift down altitude, in fact there are some obstacles on the ground, let's say for example mountains and some any other ground obstacles. So based on the en route charts, or based on the, for example, electronic flying bag that we have, EFB, or the iPads that we have, the pilot monitoring immediately will calculate the MEA, or minimum en route altitude, and will let know the pilot flying. So mostly in some of the areas that we are flying, the obstacles or the mountains will be higher than the drift down altitude. So what happens here? If we do not calculate, we hit the mountains. In fact, mostly in those areas, if we are flying, so this is the a rule and obligation for the company to calculate or to let know the pilots of the escape route maneuver. What's the escape route? Escape route maneuver is that in case we lose one engine, or for example in case of depressurization, there is need for the aircraft to descend to lower altitudes because of high mountains. There is some procedures that, okay, what to do, in which areas we should fly in order to be away from the obstacles. Now this is the time that the pilot monitoring should read the non-normal checklist, because we have plenty of other tasks to perform based on the non-normal checklist. And then we should get the weather from the alternate airport, which airport we are flying to, and just to make it a suitable airport for us. So always alternate airports are not suitable airports unless we get the weather and we find out the visibility and other criteria of the airport are not less than the minimums that we are assigned for or able to fly. Another case that should be emphasized is to declare an emergency. Mostly the ATC is asking the pilots if they are declaring emergency or not. This is a very safe and recommended procedure for the pilot to declare emergency, because we are flying with single engine, and chance of for example running out of the runway, making a hard landing, and plenty of other problems will be there. There is great chance, so much better to declare emergency, let all the firefighting and other services of the airport to be ready at the time of the landing. So as a summary and a very short review of our presentation, if we lose one engine during the cruise, there are some procedures that we should apply and some calculations that we should do. All calculations can be done by the flight management computer. The first and immediate thing that we should do is to disengage the autopilot, set max continuous thrust on the live engine, then calculate the drift down altitude, set on the altitude window of the mode control panel, and set the drift down speed in the speed window of the mode control panel, and then let the speed to drop. This is a very good time for the pilot monitoring to inform the ATC, and then once we reach to the drift down speed, engage the level change mode and heading select and turn either left or right to leave the airway. And now this is the time that the pilot monitoring should do the non-normal checklist, comply with the all procedures together with the pilot flying, and then try to get the alternate weather, alternate airport weather, and then select a suitable route based on the ATC instructions, in fact, to reach to the alternate airport. In some rare occasions, for example, damage in the aircraft engine and the internal structure of the engine, or damage to the cowling, the failed engine will produce plenty of drag. So in this case, we will not be able to maintain the flight in the drift down altitude, which is calculated by the FMC. Even the max continuous thrust, which is set on the live engine, will not be able to produce enough thrust to keep the aircraft flying in the new cruising altitude, which is in our drift down altitude. In these cases, based on the performance of the aircraft, there will be some need for the pilots to descend lower than the drift down altitude, which is calculated by the FMC. And even there will be some need for the pilots to increase the thrust on the live engine more than the max continuous thrust in order to keep their level. So these are some rare cases, as I mentioned before. That's mainly because of the compressor damage and the failed engine, because still as we fly forward, so the air will enter to the intake of the failed engine, and the air should pass from internal compressors and turbine of the engine, even they are failed. But as long as the compressor is severely damaged, so there will be block on the forward flow of the air, and with the failed engine will generate plenty of the drag. So this will cause us that we should descend lower than the drift down altitude, and we need to set more and more thrust on the live engine just to let us fly horizontal for some time and reach to a alternate airport. So thank you very much, colleagues, for watching this short presentation. I got this presentation from one of my large presentation regarding the aircraft engines that I have made for one of the flying school, and I hope the presentation or watching the video will be interesting for you. And any questions, please leave in the question box. or in the comment box of this video in time available. I will answer all those questions to you. Thank you very much, and see you back in my next presentations. God bless all.